Welcome to Winchester Cafe Sci Online, and a special welcome to those joining us for the first time. A recording of this talk will be posted on our YouTube channel, where you'll find recordings of all our online talks. I'll put details in the chat. You can also find the links on our website, wincafesci.org.uk. If you enjoyed tonight's talk and you're not on our mailing list, you can sign up for it there to be notified about future talks. After tonight's talk, we'll take a break for a few minutes before the Q&A. Please put your questions into the chat and I'll read them out. Tonight's speaker's work spans research, entrepreneurship and academia relating to artificial intelligence with edge computing, 5G and cybersecurity. He's the course director of the course Artificial Intelligence, Cloud and Edge Implementations at the University of Oxford. He also conducts, amongst others, the University of Oxford courses AI for Cybersecurity and Computer Vision. He works as a data scientist through his company, feynlabs, focusing on building innovative early-stage AI prototypes for domains such as cybersecurity, robotics, and healthcare. He's also currently working on a book to teach AI using mathematical foundations at high school level. His PhD research is based on AI and affective computing, how AI interprets emotion, and he's contributed to the World Economic Forum and the European Parliament on technology and AI themes. Please welcome my old friend, Ajit Jakar.
Thank you. Welcome, William. Great to be here, and good evening, everybody. So good. Now let's go into presentation mode then, and this is perfect. So welcome, everybody, and thank you, William, for inviting me here. And I won't talk too much about myself other than, of course, like what William said, is that I teach at Oxford University. I teach AI at Oxford University. And pretty much there are other things are the same in my LinkedIn profile. And so the course we teach is very industry focused. And this is quite important because we kind of span a unique background between research and industry. And also we are accessible to people, meaning if you do want to join something like this, it is possible, not in every case, but it does require some background. But yes, there are various courses which are possible to do that. So and of course, we got some very interesting background of students who have transitioned to AI, which is really what we are trying to do as a course, because I think that is one of the big things at the moment in terms of the skill set, because every country and whatever we think of all the changes going on, like Brexit and so on and so forth, I think that everybody has to be competitive in a world scale. And that's where I think we position ourselves, that we are able to transition people to AI. And that's really what I have been focused on quite a lot as well. And as William mentioned, I'm interested in very much the mathematics of AI. So today will be quite sort of detailed, but I will also leave a lot of time, hopefully, for Q&A. And I will assume that you do not know anything about the technical aspects of AI. I won't go into anything more technical, but we will focus more about the problem and what it solves and how it helps you in a pragmatic sense with that. So let's start with what is AI. Yes. So when people talk about AI, they see something like this. Yes, they see the sort of 1930s recession era stuff and AI taking care of all your job, taking over all your jobs and stuff like that, which is partly true. And of course, there is some truth in that. But I guess the media tends to focus on these aspects a lot more. The second thing is they look at it like this. Yes, so they think about it like the Terminator type situation where AI is going to come over and the robots are literally going to take you over as opposed to just your jobs. There's that side of the view as well. But then again, there is the other view, which is that AI is a fundamental skill, which means much like reading, writing, arithmetic, just about everything will have some form of AI in it. And I will explain why that is the case. The best way to think about AI is to think about rules and to think about a lion tamer, for example. Yes. So historically, the question is, how would you set up rules? Yes. So if you start off with a problem like chess, yes, a chess is a finite domain problem. By this, I mean that the rules of chess can be discerned relatively easily by a computer, because the world of chess is limited, because the world of chess is an 8x8 grid, and each piece behaves predictably. and every piece behaves in a certain way. Therefore, from a computer's point of view, much what Big Blue, Deep Blue versus Kasparov in the 1980s, I believe, is a permutations combinations problem. Because if it is able to discern or kind of understand every possible permutation combination within a limited set of the world, it is possible to defeat a human player. But then you have something on the right hand side, which is a problem which is relatively easy for a child to understand, but very hard for a computer. And the problem is that how will you recognize a dog in that sense? So the child looks at a dog and knows that that is a dog. But from a computer's point of view, that actually is not a very easy thing to understand. The reason why is because around the core concept of a dog, there are too many variants which fit into that. And that is really what the core issue is. And this is what I mean by it's trying to understand what the rules are. So for example, a dog could be an Alsatian, a Basenji, an Irish Wolfhound. It could be a Boxer, a Doberman, or any other breed with that. And therefore, it could have ears which are cropped. It could have a long tail, a short tail, a long coat, a short coat. And all of these are technically dogs. And therefore, it isn't possible to define a rule as in equations, as in something which you say that if this is the condition, then it's dog. And therefore it is easy, it's very hard for a computer to understand what a dog is based on images. However, it's very easy for a child to understand what a dog is. And the reason why it works for a child is because the child thinks bottom up. Yes. So when I mean by bottom up, I mean, if we look at this picture, then the problem from the child's perspective is that what are the characteristics of the dog? Yes, a dog has whiskers, a dog has a nose, a dog has long ears, or is friendly, or so on and so forth. And therefore, the question is, if given enough data, given enough examples, or given enough use cases, would you be able to automatically determine the features of what constitutes a dog? And the way that works is using an algorithm called deep learning. And deep learning, in the very simplest sense, is what I have described here in the picture. So for example, you have a picture of the objective of this problem is to determine what is the picture of a woman in this case. Yes. So what happens is it works bottom up. So the lowest layer of the deep learning neural network identifies pixels, the one above identifies sort of edges, the one above identifies contours, and then identifies features, for example, the headband of the woman, and so on and so forth. And the last layer is the classifier, which it says whether it's a car or a person or a dog. And when you have something like this, what you have is that you do not tell it what constitutes a dog, or in this case, a woman's picture. What it does is it automatically determines what are the features which make up this entity. And it does so by looking at a large number of input-output pairs. Yes, so what you do is that you give it a large number of examples, and those examples will say that this is a woman or a cat or a dog or something like this. And each of those examples, the computer or the deep learning neural network flows through the network bottom up, meaning that each layer builds up on top of the subsequent layer, and it is then trained to determine what a particular thing is. In this case, a picture of a woman. And you do this repeatedly. And this is what is the meaning of the word deep learning effectively, because it is learning through layers. And so if you have to define these terms more technically, we can say that machine learning means that you explicitly train an algorithm. Deep learning, which means you automatic feature detection, which is what we have done here, meaning that it has automatically detected what are the features which constitute something. Then you have artificial intelligence, which means machines that can think and reason based primarily on deep learning algorithms, meaning algorithms like these. Yes. And then you have effectively, there are two types of AI. One is narrow AI and the other is general AI. So just about everything we are seeing today is narrow AI. So narrow AI meaning that AI applied in context of a specific problem domain. For example, healthcare. Yes, general AI is the basic thing which we saw in the Terminator picture. Yes, so that a general AI constitutes that that AI can operate almost at human level into any domain interchangeably. Yes, so that really is pretty much science fiction at the moment, and this is partly what happens a lot with a lot of the hype around the media, is that people tend to sort of get confused between one or the other, and they tend to think about general AI when realistically we still are pretty much in the narrow AI realm. In terms of statistics, or in terms of if you come from a sort of mathematical background, these problems are relatively pretty straightforward, and they build up on classic statistical problems, which is classification, regression, meaning trying to find a straight line or a curve, attribute importance, anomaly detection, clustering, and so on and so forth. The difference between those algorithms and statistics and effectively the sort of the deep learning algorithms is that in these cases you are typically dealing with multimedia, effectively what we saw, pictures and so on and so forth. And the second, the more kind of a subtle difference, is that these features are at a higher level of abstraction, meaning that you are not saying, you are effectively leaving the network to determine what constitutes something, but at the higher level you are saying whether this is a woman or a cat or a dog. Yes, so you are continuously training the images based on a certain response, but it is left to the network to determine what constitutes that particular object. And that is what makes the difference between the deep learning neural network and the historical statistical neural networks. There's another quite interesting sort of a mathematical property of deep learning neural network. And if you kind of recollect your high school maths, the image on the left hand side is the equation of a straight line. And that is basically an equation of y equals to mx plus c. The equation on the right hand side is actually unclear. Yes, so it is not very clear what is a function which describes this particular image here, curve here. And the reason why that matters is because with a deep neural network, given enough layers and given enough data and given enough CPU, it could in theory represent any function. And why does that matter is because everything is a function effectively. So you can think about Siri as a function, you can think about self-driving car as a function, effectively that you have an object which is doing something, and it is fed with a certain amount of data, and it is trying to model the behavior of that even when you do not know what how you define that behavior, much like the example of the cat or the woman in that sense. And much of deep learning sort of is already with us. Much of AI is already with us. Things like Siri and facial detection and so on and so forth. All of these use AI techniques. And in that sense, this is what I mean by it's pretty much here with us now. But it's not kind of just cats and dogs. It's sort of very serious stuff like tumors, for example, genomic sequences and so on and so forth. So it's kind of pretty much already with us, much of what we are describing as AI. And the reason why it's so disruptive is because it is so pervasive, meaning that it applies to just about any domain, given enough examples of it. And these algorithms continue to improve, and they continue to do functions which are very disruptive in terms of what's possible. So in that sense, that is how AI is disruptive to jobs, and it will continue to do so. So if you look at what I have tried to describe to you before, it's pretty much actually applicable to anything, not just images. So for example, the top one is images, but it could also apply to audio. It could also apply to text, which is why you have natural language processing and things like these. So effectively, it doesn't matter what data it is. If you label it, if you have enough labels of it, then it is able to discern what the underlying pattern behind it is. And that's how Spotify works, for example, trying to find out an audio sequence of what the song is. And that's how all these areas work in that sense. So I could describe this in another way. Now I'm sort of trying to describe these not as mathematics, but more as sort of problems and what problems can be solved. So for example, we could talk about things such as what are the types of problems AI could solve. So AI could be a domain expert, meaning that it could effectively think about replacing a lawyer. So I know people don't like to replace doctors, but people are very happy to think about replacing lawyers. And effectively what that means is that given enough examples or historical examples of legal cases, AI could replicate that function pretty much. It could replicate the accounting function as well. For example, double entry bookkeeping or stuff like that. You could think about extend that idea to domain extension, meaning that given a body of knowledge, you can find new knowledge. So for example, you can find out new techniques like drug discovery, for example. Yes, you can find new medicines. For example, COVID pretty much was sort of AI was involved into the solutions. You can think about complex planning. For example, think about operations research, but with a very large number of parameters. You can think about better communications, which is effectively chatbots. You can think of new sorts of perception, which drives things like autonomous vehicles. You can think about AI in second order consequence problems, for example, in insurance. You can think about problems that could benefit from improved algorithms. For example, language translation, which for a long time wasn't good enough, but at some point the algorithm improved enough so that it could be kind of mainstream, used in mainstream applications. Or finally, you can think of super long sequences. For example, Uber, the self-driving car, or any self-driving car has a super long sequence problem, because you have a very large sequence of things and you want to discern something from that. So another way to think about it is in terms of examples, what is possible, and these are all real life examples. So for example, you might have seen something like this, that AI can present, can paint as good as Rembrandt or anything like this. And the reason why that works is because, again, it has learned how a master artist draws, and then can mimic that behavior, much as what I showed you before. So there is two sides to it. Firstly, there is a discriminative side where it learns how something performs, and then it is a generative side. So having learned a distribution or a theory of how something works, in this case, how Rembrandt paints, or any artist paints, then it is able to kind of create more images in that style, so to speak. Yes. Then there is things such as the same could apply to music, for example, because remember I said to you that it doesn't matter what the format of the content is. It can be pretty much anything with, and the same applies to music. So AI can compose music like Bach, for example. Yeah. It can apply to doodling or handwriting or signatures or anything like this. The given enough examples of something, it's possible for a deep learning neural network to learn that behavior and then to subsequently mimic that behavior in a generative sense with that. This one's interesting. So AI can predict how long your relationship will last. Yes, and this sounds a little bit weird but if you could think about it in another way. So, for example, if you look at it from a relationship counselor point of view, you can think about it that the human being is sort of asking two people a set of questions and trying to understand their responses, and trying to understand how their relationship would progress with that. But in the case of AI, that would be quite different. So what it would do is it would sort of try to understand or correlate your actual voice, for example, against your emotion. And if it had seen enough examples of people behaving and talking in a way which was inconsistent to what they were saying, effectively it could say that you are inconsistent in what you express. For example, if you say the word "I love you," but where you're not quite sort of have the same tonality, that's how it would work. So effectively, AI could work or perform certain functions in quite a different way than traditional human beings would perform. Debatably, whether that is right or wrong, or it should be or shouldn't be, that's a more of an ethical debate. But from a technical point of view, that's how this would work, and pretty much is working right now. AI can be a chef. So this is the London-based company. It's a company which creates a robotic kitchen. And the way that works is because in this case, the robot has learned by watching a chef. So what it does is pretty much observe how a chef sort of cooks and finds the recipe and then kind of learns from observing that chef alone. And this is a powerful idea because just learning by observation is a very interesting way to train a robot without explicitly telling it anything. The only thing you tell it is that whether the final result is good or bad. In that sense, for example, you would say that the final dish in this case tastes good or does not taste good, and that's how you would work with that. This is the Japanese farmer who created a way to sort cucumbers. And this is the sort of sushi way of making things. And of course, the cucumber has to be very accurate, and it has certain conditions of texture and so on and so forth. And the sorting machine effectively had a camera which was able to understand which of those cucumbers are good and which are not. The same idea works with sorting fish on a trawler, for example. So it could effectively separate fish you want versus fish you do not want, and so on and so forth. So all these ideas are pretty much based on the same concept which I started off explaining to you with the picture of the woman, because all of these, whether you sort cucumbers or whether you try to sort of paint like Rembrandt or things like that, are all based on the same basic idea that you are able to understand the characteristics of a particular domain based on a large number of labeled examples of that domain, and then the machine effectively, or the algorithm effectively, learns how that problem functions and is able to subsequently either separate examples as in cucumbers or generate examples as in music of Bach. So this is the sort of the one sentence of how AI works. Pretty cryptic a little bit, but I think if you kind of followed a little bit of what I said so far, it would make enough sense. That the key is it needs enough examples of something to be able to understand one way or the other what's happening with that. So what are the type of future AI applications? There are a whole bunch of algorithms which are happening. Some of these are here. I won't go through them. The important thing to realize is that AI is an extremely rapidly evolving field, and it's pretty much a full-time job to sort of track these things and see how they evolve. Partly because there's such a lot of brain power being thrown at it, and a lot of the hubs such as Oxford, Stanford, MIT, all of them tend to sort of produce papers all the time, which continuously push the boundaries of what's possible. So every now and again you see something which is absolutely brilliant, and so on with that. So how does this apply to you, for example? So the first point is AI will be everywhere, as I said to you, and this is an example I got from the internet, but it really shows you that there are not many fields which do not include AI in some shape or form. The other thing to remember is that AI as defined in an industry is quite a different idea. So for example, if the way we work in Oxford or the way a large bank would work or something like this would be that you actually have 3 jobs and not 1. So the classic AI job, algorithmic job, is sort of the thing which I'm talking about, effectively looks at either machine learning or deep learning algorithms. But on either side, you have 2 other roles. The first one is the data engineer. The data engineer is a person who takes in data and kind of manipulates that data such that it is suited for the algorithm to process. And on the other side is the DevOps engineer, who takes the model which is trained by the data scientist and then deploys that model to a larger a set of platforms. Yes, so effectively you have then 3 jobs and not 1. And this is again another bit of confusion with people because they sort of look at the whole thing together, but each of them are pretty much specialized jobs, and they work in that sense. So what we're talking about here is pretty much how you see these words like Kubernetes and containers and so on and so forth. And that is why they arise with AI. And then the whole domain of AI in that sense is what we teach at Oxford is called MLOps, which is DevOps and machine learning and DevOps with that. Yes, so that's how the world works. So what do I advise for startups is to pretty much keep it pragmatic. Sort of don't think too much about what the media talks to you about. Think instead of about sort of improving experience. Think about intellectual property, because I think there's a lot of intellectual property with AI. And in that case, it's the model being defined as a data and algorithm. The third bit is that you do not necessarily need to own the data. Somebody else could own the data, but you need to effectively have the model which best depicts the problem. Um, it needs to solve a hard problem. This is an important thing as well, because not all problems lend themselves to AI, because AI is an expensive solution. It involves a lot of time and cost and money. It is something which you definitely want to sort of work in that way. And finally, you want to think about improving a state of the art. So for example, fraud detection, any problem, for example, can be thought about. You can improve that problem by kind of building a machine learning or deep learning algorithm which improves that state of the art. If you're an SME, you don't want to invest all this money, then perhaps you can think about simpler stuff. So for example, you can say, understand AI. This is the first part. So understand it from a more pragmatic point of view, much as what I'm trying to talk to you about. So don't get too kind of carried away by the hype of AI. And there is a lot of that. Then think about effectively improving a process. Think about a business problem and think about the context of a business problem, and then think about how you could improve that. Look at automation. I think automation is an important thing, because I think that you would tend to automate just about everything, and together you can sort of improve or automate any process. And the reason why that matters is because automation in general is one of the sort of drivers of AI. And this is perhaps a little bit more controversial. You can think about jobs and all those sort of things, but from a practical or a pragmatic point of view, you can think about AI which tends to realistically automate anything. And if you look at the industry, for example, people tend to automate expensive jobs. So for example, cybersecurity, legal, and human resources, which would be functions within jobs. I'm not talking about automating the whole job, but there are certainly functions within a job which you could automate. And that's what AI would end up effectively doing. Explore the cloud platform. So we are very sort of bullish on cloud platforms. And by that, I mean things like Azure, Google Cloud, or Amazon Web Services. Now, of course, cloud has both a pro and a con, because while cloud platforms make things easier, you effectively end up paying for them as you use them. And that, of course, creates a certain amount of resistance beyond a point. But it is both-sided, meaning that the cloud platforms have made tremendous progress in terms of all these things. They tend to make things easier. They have very low but none actually effectively upfront costs, because they always give you some kind of freebies to start off with. So you can do a lot of these things almost on without any expense of your own, if you choose the right strategy. That doesn't mean that you wouldn't have to pay for it. You would, of course, as you grow. But my point being that you don't have to start from zero and buy a server and install software or things like this. Pretty much you can start off with a browser and do quite well with that. And as your needs improve or the needs increase, you can then retrain the model from there. Explore AI for analytics. So I think that AI for analytics is quite interesting, because it is so common, because just about every business has analytics within there, and depends on how you implement those analytics, you pretty much can do a lot with that. And finally, implement machine learning. So what I'm trying to say here is that when I explained to you right at the beginning, algorithms like regression, classification, and so on and so forth, they tend to be traditional machine learning problems, and many cases they would do perfectly fine. So you do not need to have a deep learning problem. You don't have to have algorithms which are very complex. You can do quite well with simple algorithms, which would still give you a lot of results with that. The reason why that works is because many problems can be defined into very simple terms. Pretty much in spreadsheet like data. And if you are able to do that, then you may not actually need much of the things I have described to you. But that's where the spectrum of possibilities is. So you could effectively try to implement something quite simply, or you could deploy more complex algorithms. So this if or completes my presentation. So what I wanted to quickly recap while we have got a little bit of time is sort of the key ideas here, because I know I've sort of introduced many ideas which might be quite new to you. So just to recap, what I'm trying to say is that there is a lot of hype in AI. And that's what I mean by all these things going on, including the sort of talking about the Terminator and so on with that. Then the next thing is that AI is a fundamental skill. And that is definitely going to happen, because there is not any other ways in which you can do these things with that. Then the third thing is all about trying to find rules. Yes, so you could do rules in three ways. First of all, you could explicitly define the rules, which means that you could have an if then else statement for every possible scenario. And that looks obviously possible, but not practical. So you could not, in all fairness, anticipate every scenario. The second possibility is that you could learn rules from the data, and that's what machine learning does. So you have effectively something like classification problem or regression problem, and those are pre-trained. The algorithm of the data is used to train the algorithm to understand that. And the third way is that you could both learn the rules and the structure of the problem from the data, and that is what we were talking about through the whole session. Effectively, is that we are talking about things like chess, where the structure of the data is relatively easy to learn. And when that was the case, you had the sort of the Deep Blue versus Kasparov situation. But then you have something like this, where the structure of the data is not easy to learn, and that's where you have deep learning algorithms. And then you kind of distinguish them between the traditional algorithms, but also the fact that the deep learning algorithms have their own interesting properties, and they tend to be applied pretty much across the board, including things like facial detection, object detection, sound, and so on and so forth. And they tend to be applied to more serious things such as tumors and genomic sequences and so on. And interestingly enough, they also tend to be applied to any type of data, which includes text, audio, images or video, and so on. And then you have a whole set of problems which are possible uniquely with AI. And I explained to you things such as you can think about chatbots, you can think about complex planning, and so on. And then you we looked at different applications within AI, and some of them sounded a little bit different, but some of them included mimicking something, for example, a famous painter or even a musician, even your own doodles. And then you could think about some oddball applications, like just trying to find out whether a relationship would work or not. And then you try to mimic a chef, or rather be a chef as AI. And you could then go on with that. You could sort cucumbers because they are images and you can train them, and so on and so forth. And then finally, we looked at what it means for you, meaning that what it could mean for the different type of areas, different areas of applications. And then you could also what it means as a company, meaning that if you're a large company, then you have three roles or three jobs which are possible. But in traditionally smaller companies, you wouldn't kind of go in such a big way. And that's how the whole actual implementation of AI tends to be much more complex. You tend to hear words such as MLOps, Kubernetes, that type of thing, but they all are the same idea, that you have somebody who develops algorithms, somebody whose job is to bring data to the algorithm, and somebody whose job is to deploy that model, which is trained by the data scientist, onto a number of devices. So this is why AI as a subject It's quite complex because it is sort of both a breadth and depth, which is pretty much what we teach at Oxford as well, including images within there. And then I talked to you about what could you do as an SME if you so wish to get into AI, and it has some interesting examples. So, for example, there are many products which already implement AI, and you could pretty much kind of piggyback on top of them. And then I talk to you about the cloud, because I think the cloud platforms tend to make your life a lot easier in terms of implementing different AI.
That brings us to the end of the formal meeting. Many thanks indeed to Ajit for an enlightening talk and a very engaged conversation and some very good question and answer discussions. We look forward to seeing you next month. We'll be back on Monday, the 1st of February with Winchester College. Goodbye.